first period. Hope you guys had a great Wednesday. Today, we are going to take a look at this application problem from yesterday's notes, so the 8.4 notes. And you're also going to want to get your calculator out. So go ahead and do that. And we'll get started. So calculator, 8.4 notes. Here we go. So we just need to finish this application. There's another practice, all right? So according to a Common Sense Media survey of 910 randomly selected U.S. teens, 57% reported watching TV every day. Watching TV includes watching programming from a broadcast or cable network on a TV set, watching shows that were recorded on a DVR, or streaming shows to an internet-connected device with a subscription service such as Netflix. We're going to first construct and interpret a 99% confidence interval for the true proportion of U.S. teens that would report watching TV every day. And then based on this interval, we're going to see if there's convincing evidence that a majority of U.S. teens would report watching TV every day, and we will explain why we believe that. And then if the researchers wanted to reduce the margin of error to at most 1%, about how many additional teens would they need to randomly select, and we will use the value of p-hat from the initial study. So that is a difference from yesterday. Yesterday, remember, we used a p-hat of 0.5 because we had not done the survey. And so this one's telling us we're going to use the p-hat from the initial study. So we'll end up using the p-hat of 57%. Okay? All right, so let's get this started. Construct and interpret a 99% confidence interval for the true proportion of U.S. teens who would report watching TV every day. So we're going to follow that same format that we had on our notes yesterday, on our example that we did with the globe. So we're going to follow that same format. You guys will pretty much always have access to this format, or it'll be kind of on the page for you. So state, for the confidence level, all right, the confidence level, we're going to have a 99% confidence level. And the parameter is we're going to estimate P, the true proportion of U.S. adults who, U.S. teens, my bad, of U.S. teens who would report watching TV daily. All right, so we've got our confidence level and we've got our parameter, our true proportion of U.S. teens that would report watching TV daily. Now we're going to do plan. So the first thing we're going to do is we're going to identify the procedure that we're using. This is the same one from yesterday. This is a one sample Z interval for P, the true proportion. And then we're going to check our conditions. All right, we're going to check those conditions. The first one is going to be the random condition. And we do, in fact, have an SRS of 910 U.S. teens. And for our normal or large count, we're going to check that N times P hat is greater than or equal to 10, and N times 1 minus P hat has to be greater than or equal to 10. And so we're going to check this. N, our sample size was 910. Our P hat, that is the 57%, so 0.57. When I do 910 times 0.57, we get 550 18.7, but I'm going to go ahead and round that to 519. Because again, remember, this is going to be our number of successes, and I can't have a decimal number of successes. Okay. For our complement, we have 910 times 1 minus 0.57. Okay, so that would be 910 times 0.43. And 910 times 0.43 is equal to 391. That is greater than or equal to 10. By the way, that's the number of failures. Basically, that's the number of teens that are not watching TV every day. And success is 519. That's the number that are watching TV every day. Seems kind of backwards, but that's what it is. So now we can say all conditions are met. All conditions are met. So we've stated, we've planned. Now, unfortunately, I'm out of room. Hopefully you still have some room, but I'm going to go ahead and erase what we have here so that I can continue writing. Hopefully you still have room. If not, you might want to turn over on the back of the paper if you need to. All right, do. We're going to use, do. For do, we're going to use our calculator, and we're going to go to stat, test, A, which is the one prop Z test, or interval, sorry. It's one prop Z interval. All right, X is our number of successes. And so we're going to use that 519, that was our number of successes in our sample that we just calculated a few moments ago. N is our sample size, and so that is going to be the 910. And then our confidence level, that's going to be 0.99. That's our 99% confidence level. So we'll go to stat test A, and we've got 519, 910, 0.99, and calculate. And it gives us 0.528 to 0.613. That means that somewhere between 52.8% and 61.3% of U.S. teens watch TV daily. All right, we're going to conclude. This is our sentence. We are 99% confident that the interval from 0.528 to 0.613 captures the true proportion of U.S. teens who watch TV daily. So that is our state, plan, do, conclude, our 4-step process. Okay. All right, let's see what number 2, our follow-up question here says. It says, based on our interval, is there convincing evidence that a majority of all U.S. teens would report watching TV every day? So our interval was 0.528 to 0.613. A majority is greater than 50%. That's what a majority is. It's when there's something greater than 50%. Okay? And if you look here, all of our plausible values are greater than 50%. So, since all plausible values are greater than 50%, it seems we have convincing evidence. All right, and now for the algebra problem. Here we go. If the researchers had wanted to reduce the margin of error to at most 1%, about how many additional teens do they need to randomly select? And we're going to use the p-hat from the initial study. So we need our margin of error to be greater than or equal to the z-star critical value times the square root of p-hat 1 minus p-hat over the sample size, which is the standard error. All right, so let's plug and chug. We want our margin of error to be at most 1%. That is 0.01. Now, we need the z-star critical value for 99%. Okay, because it doesn't say that we're going to change our confidence level. So back in the notes from 8.3, you had 4 confidence interval levels that I gave you. You'll always be provided these, and so the z-star for 99% is 2.576. So that's what we're going to use here for the z-star critical value, 2.576. Okay. Now it tells us that we're going to use the p-hat from the initial study. So we're going to go ahead and use that 0.57 because that's what they told us to use. I am going to go ahead and do the 1 minus p-hat right here, okay? So I know that 1 minus p-hat is just the complement of the 57%, which is the 43%, okay? And then we'll divide by the sample size to see how big we need to get it. This is now just the algebra. So first step, we're going to divide both sides by the z-star critical value. Okay, and so we take 0.01 divided by 2.576, and we get 0.00388 is greater than or equal to the square root of, all right, I'm going to do another thing here in this step. I'm going to go ahead and multiply those two numbers together. So when I multiply those two numbers together, 0.57 times 0.43, go ahead and multiply those, I get 0.2451. Okay, so I'm kind of combining a couple of steps here, and that's what we get. All right, next step. Now that our square root sign is all on its own, we can now square both sides. That way that square root goes away, and I'm going to square this side as well. Okay. I'm going to move up here now. All right, so if I take 0.00388 and I square it, I get 1.50544 e to the negative 5. Okay, and remember, that's very important. And that is greater than or equal to 0.2451 over n. All right, we said that e to the negative 5th, that means we need to move our decimal places 5 places. Okay, so we're going to have 0.000150544 is greater than or equal to 0.2451 over n. I know that's a really ugly decimal, but that's what we've got. Now we can multiply both sides by n. Multiply both sides by n. And we have 0.000150544 n is greater than or equal to 0.2451. And the final step is to divide by that big decimal. We'll divide by that big old decimal here, and that'll get our n by itself. And n has to be greater than or equal to, let's see, 0.2451 divided by 0.124150544. And we get 16,280.95. Again, we have to round that up to the next number. So n would be 16,281. But that's the total. And so we need to know how many additional teens do they need to randomly select. They had 910. So we need to subtract 910, and we get 16,281 minus 910, and we need 15,371 additional samples. All right, that's how it goes. All right, you guys, so I want you to work on your sapling for 8.4. It's going to have a lot of this same stuff in it. You're going to see the 4-step process. That's going to feel really easy. Make sure you're utilizing your stat test A in your calculator, okay? And then you're going to have a lot of these where you're going to have to find the sample size. Sometimes it might not ask you for the additional. It might actually ask you for the total. And remember, if you are not given the sample size, use 0.5 as your p-hat estimate. So you're going to work on your sapling 8.4 today, and then tomorrow you guys are going to do a group quiz over 8.1 to 8.4. Just kind of to see kind of where you're at and to make sure that you're, understanding everything, and so you can help each other understand all of what we're doing, okay? Y'all have a wonderful day, and I will see you guys on Monday.